Hi all. I'm going to present my work Fine-Tuning Human Pose Estimations in Video. My name is Digvijay and the co-authors of this work are Vineet Balasubramaniam and C.V. Jawahar. Human pose estimation is a very fundamental problem and a lot of research is going on. There are two types of data that this problem deals with, still images and videos. For this particular research work, we are dealing with video data. So the motivation behind the proposed methodology is that single frame models like DPM, they provide reliable estimations for generic settings like frontal's human pose, and video data has redundant and temporally synchronous information. And so in DPM models, the pairwise constraints they force Unity to produce false estimations. As you can see in the image, the left elbow to wrist estimation is going wrong because of limb foreshortening, and pairwise constraint is forcing Unity to make false estimations. So the challenges that we generally face with this problem are self and external occlusion, clothing variation, which can alter the human silhouette, limb foreshortening, and illumination variation. Whereas with video data, we have motion blur and fast limb movements, which can be very difficult to track. So in this work, we are also introducing a new data set for sports videos. These are 11 sports videos, and the post configurations are extremely complicated. From our observation, we have seen that from all the public available datasets, our dataset has the most complicated pose settings. The other datasets that we have used for experimentations are poses in the wild and video pose. So I'm going to briefly talk about the method here. So firstly, how a standard self-training pipeline works. So we have a base model, which is a DPM model in our case. It gets a testing data. So base model generates estimations, and we have a batch selector, which ranks just using the model score. So from the top detection, uh, using the top detections, we retrain the base model, and we do this step iteratively until we are satisfied with the output. So how we have modified the self-training pipeline, instead of having a single base model, we have a base model, we have an amalgamation model, which is a combination of base model, which is DPM again, and an ensemble of exemplars. So here we are talking about the first iteration, so ensemble is empty. So we are getting test data, base model is generating estimation, and the batch selector here is again improved to improve the performance. So we have a post quality score criteria and again model score. So what do we mean? What do we mean by post quality score? We have it generally characterizes based on the geometrical configuration of poses and its visibility. So now the top detection that we get now, they are transformed into exemplar SVMs and they are augmented into the ensemble. So now we have an amalgamation model which takes input from the base model as well as the ensemble. So this performance shows that from the traditional models we are beating the state of the art on most of the datasets. So these are some visualizations which look, I mean, good because they have been cherry picked. So my poster number is A8, and for more details, please visit. Thank you.